Hello guys, and welcome to the Drowsy Neon Matlab beginner tutorial. In the previous lesson, we learned how to use the editor window, the command window, and observe the changes in the workspace. So today, let's move on to the next part of the lesson. Originally, learned that in the editor window, for you to run the code inside the editor, you have to run. And when you run it will require for you to save before it runs. So let's just save it on our desktop. The format for Matlab saved files are .m or any other file. So .m files can be opened with any editor, whether Microsoft Word or any editor. You'll be able to read it because it's basically text, but Matlab reads it in .m format. So let's call it beginner lesson. Let's save. Yeah, because Matlab doesn't really take space. You can use underscores and it will work. So we have to wait for it to run. In well, has it run already? Yeah, that's it. It has run, and you can see that it has given us the answer for the previous one. Let's change a value here. Let's make that Z. You see that it has run. Now for the next part of the lesson, we are going to learn how to run in sections, just in case you have more than one or two sections of code. You'll be able to run the first section separately, independently. You run the second section independently, because this run button just runs everything on the editor window. So to create a section, you have to use the percentage sign. Just go double percentage and you see it creates something like a section. You put in your space and then you can put in the title of your section. Let's call it second section. Okay, now this part of the code will run when you run this section, it doesn't include this first part of the section. It just runs anything from here. You can create 3 sections, 4 sections, 5 sections. You can create a number of sections and you can run them independently. Okay, so for this section, let's go that is equal to 30, and let's go okay, let's go Z times pi. This is pi. This is how Matlab saves pi. So this pi value is obviously the default pi value. Okay, so let's run this. Let's run section. When you run section, it just runs just this. Okay, so let's clear the screen before so that we'll be able to see exactly what it is doing. Okay, so this basically gives you 30 times pi. Okay, let's be sure the value of pi is that. See, this is the value of pi. Okay, so when we multiply it by z, we get 30 times pi. So you can run this section separately over here. You can run this section separately and it will work for you. Okay, so ignoring sections. The next part of our lesson is to see how we can plot values on the graphics window. Okay, so that isn't really too hard. Okay, let's close that. Let's make x a range. For you to make any variable or to declare a range, you have to use the colon symbol. Okay, the colon symbol is basically an is-to. Okay, so you can go 1 to 20, and then when you run this section, it gives you values from 1 to 20. Okay, so this column is basically what determines a range. Okay, so you can go 1 to 20. Let's go 1 to 50. Okay, so it gives you values from 1 to 50. Other ways to, let's delete all this. Other ways to determine a range is to use the lane space, but let's ignore the lane space for now. In using the range, right, you can this range has unit steps, right? The steps for this range is 1. So from the first value to the second value, the step is 1. It jumps 1 1 1 values all the way to 50. You can change that and make the steps 2. This is usually used to, you know, to maybe find odd numbers from 1 to 50, right? You need step when the step is 2. Let's make the step 5, and you see it gives values 1, a step of 5, then the next value is 6, step of 5, the next value is 11, step of 5, the next value is 16. So that is how we can determine ranges. Okay, then we have the next means of determining ranges, and this is called the linspace. Okay, for linspace, it gives you values from one point to the other in a total number of values you want. So let's say I want values from 1 to, use the comma in linspace, from 1 to 20, and I want a total number of 100 values, right? Let's close this so it doesn't interfere with the work. So when you run this, let's observe it. When you run this, it gives you 1.119 all the way to 100, all the way to 20, but the number of values are from 1 to 100. So it gives you a number of 100 values from 1 to 20. So this is mostly used as a shortcut method to, you know, when you want a specific number of values in a certain range, right? So it just steps it all the way. The steps are not known. It just steps it until it can give you 20.0. So depending on the range you use, you can get a total number of values. That's how linspace works. So yeah, that is the gist of the ranges. You can also go negative ranges, but let's ignore that for now. Right now, let's work on the plots. Let's say z, let's go for a linear plot. Let's call z to be 5. Okay, so to call a plot, we use the keyword called plot. Okay, simple, right? So let's say we are working with a linear graph, right? From this is already linear. Let's remove the steps. Okay, so values from 1 to 50. So you can just plot these values, plot x from 1 to 50, and let's see what we get. Okay, so you get values from 1 to 50 on both sides. See, so this becomes 1 to 50, this becomes 1 to 50. Okay, let's say we want an x-axis and a y-axis. Okay, so you can go plot x comma, let's make y, this y our y-axis, x comma y. When you run this, we should get an error. Let's make this 10 values. I wanted to show you the error. Yeah, okay. So what happened was that Matlab telling us that error using plot, vectors must be the same length. Okay, so when we are plotting x comma, we take the first value of x, we take the first value of y is 1. When these are a number of 25 values, but these are about 10 values, oh no, these are 50 values. Yeah, over here, 50 values. So this one is the y values are 2 times more than the x value. So for plots, you have to get an x comma y for the first point, x comma y for the second point, x comma y. You get the gist of it. So this is where linspace really plays a serious role. So over here, we can say 1 to 20. These 25 values, right? So we can say we also want 25 values here, and then when we run it, no error. So you see, on the y-axis we have 1 to 20, on the x-axis we have 1 to 50, exactly as we displayed over here. So linspace is really beneficial when you want to plot. It's very useful. It's a useful tool. You can use it for, you know, a whole lot of stuff. You can also get 3D plots. You can plot 3D plots, you can plot mesh plots, you can plot a whole lot of different kinds of plots, which we will treat on next lesson. Okay, so let's try something here. Let's call it t. T is equal to 1, 2, call it 300, right? No, that didn't work. Let's go 25. Around. Let's try to include t and see what exactly happens. You get an error. Yeah, we got an undisplayed error right here. It said data must be a single matrix y or a list of pairs x comma y. See, this is a 2D plot. Okay, so to create a 3D plot, right, you just do plot 3 and then x, y, and z values all on this plot. See, this isn't really graphic, you can't really see anything, so we can use a grade on, right? Grade on is a function in the display, in the graphics window, that lets you put on the grid so you can see exactly what is going on here. So you can change the colors of the plot, you can change it from blue, you can do all those stuff here, but most of the time it's you know, nicer to do it on this editor window. It's very useful. So there are a lot of ways you can use Matlab for plots, graphs, pie charts, which we will study later on. There are so many useful tools, but that is just a simple 2D 3D plot, which, you know, works out. It works out perfectly. So meet you later for the next lesson, where we'll be looking at loops and using functions and equations. So don't miss it.